In this video, we will build an assembly which will help us build a corridor. An assembly is one of the basic building blocks of a corridor, and it's an essential piece of that corridor puzzle. So let's start building an assembly. In order to do that, we have to start here on the ribbon in our Create Design panel, and under the Assembly drop-down, we will create an assembly. And again, this is the main building block for our corridor design. And to this assembly, we will add sub-assemblies, smaller building blocks. But it all starts with our assembly object. And so here I'm going to name this assembly, and in this video we will create an assembly for a full road. So I will call this a full road assembly, meaning we're going to put 2 lanes on either side of our assembly object, and we will attach some curb and gutter and some sidewalk with boulevards and then a daylight object. But before we get too far ahead, I'm going to name this. I could give it a description, which I will leave blank for now, and there are many different assembly types. We can just leave the default other type for now, that's fine. Same with style. Basic style is a good place to start, as well as the all codes set style and the default layer. So I will click OK, and then my cursor is telling me to specify the baseline location for this assembly. So I like to keep track of them. They're rather small compared to our drawing scale. So I'm going to put it between my surface and the profile. That's an easy place to find it. And once I click, we have this basic assembly, assembly object, or the anchor point. So now it doesn't look like much of a road at this point. We need to add some other parts to this assembly. And so I will, in my ribbon, turn on the tool palettes. You can see mine is not highlighted, so I will click on that, which brings up our different sub-assemblies that we can attach to this assembly base point here. And this is going to represent the center line of our road alignment. So I will start with a couple of lanes, and you can find the lanes, all kinds of different lanes here in the lanes tab. And if you are looking for a tab that you can't see, down here at the bottom where all the tabs stack up, if I click on that, then it gives me all of the possible tabs that we want to look at. So here there's lanes, shoulders, medians, curbs, daylight, something called generic or conditional, trench pipes, retaining walls, rehab, bridge and rail. Also at the top we have basic imperial assemblies, and then something just called basic. And there is a basic lane in this basic tab, but I'm going to start with the lanes tab, and I'm going to take this top sub-assembly called lane super elevation, and I will click on that, and I will continue through this message. So I've selected my sub-assembly for lane super elevation, and it's asking me to select marker point within assembly. So where do I want to attach this lane? And if I move my cursor over the assembly here, you can see it lights up the center marker. And if I click on it, then I have a right lane. If I click on the left side, I get a left lane. And I could attach multiple lanes on either side if I wanted to, but for now a 2-lane crowned road is just fine. So I can escape out of that command, and if I zoom in a little bit here, so I'm zooming into the end of the lane sub-assembly, and you can see these little circles here represent different attachment points for our next part. So again, 2 lanes that I've attached to what is a center line attachment point. And you can see we do have some slope on these lanes, and the lane has multiple layers of different pavement layers and base and sub-base layers, and we can set the parameters for all of that just by clicking on that sub-assembly and right-clicking and going to sub-assembly properties. So here we have the name of that subassembly that I chose, that lane super elevation, and there are parameters in the parameters tab that I can set. So for example, lane width. In this case, a 12-foot lane is fine. 2% crown is great. And then we can set some other parameters here, like pavement depth. So let's say I want a 3-inch wear course layer, so a 3-inch top pavement layer. And I would set this to 0.25 feet, or a quarter of a foot, which would be 3 inches. Same with pavement 2. Let's say I want 3 inches, 0.25. Base depth 4 inches would be this 0.33 feet. Let's say I want 6 inches, and we'll call it 0.5. And a sub base depth of 1 foot looks fine. So super elevation, in this case, we're not using any super elevation, even though it's called the super elevation subassembly. We'll leave this to none for now. Sloping away from the crown of the road, away from the center line, which is really all we need to talk about right now. So I will apply and OK. Now I could go in and do the same thing for my left lane. Again, parameters tab. 12-foot width is fine, 2% slope is great, and we change these to 3 inches or 0.25 feet. 0.25 feet. And our base depth, base 1 was 6 inches or 0.50 feet. And apply and OK. And you can see when I did that, it did change the thickness of my pavement layers. We left the width alone and the slope, so those didn't change, but the width layers of these different pavement layers did change. So we've got our lane. Let's say this is an urban road we're designing, so what usually happens at the edge of a lane is some curb and gutter. So if I go into the curbs tab, we have all of these, let me close that, we have all of these different curb subassemblies, and there is also some basic curb and gutter in the basic tab, but I'm going to go to the curbs tab, and I'm going to use let's say urban curb gutter valley 1. So, and continue. So I am now in the curb and gutter tool, and it's asking me to pick a marker point. Where do I want to attach my curb? That looks like a good place to attach it. And you can see in this case, this is a surmountable style curb. If we wanted to change our assembly type later, so let's say I decide I don't want a surmountable curb, I wanted something else altogether, I can click on these subassemblies and simply delete them. So let's say I wanted a bumper style curb. Let's use this basic curb and gutter, and I can click on my attachment point, and here we get a basic curb and gutter. And again, we could change parameters for this curb and gutter if we chose to by clicking on it and going to right-clicking and going to subassembly properties. And then in the parameters tab, I could change all sorts of things: gutter slope, gutter height, width. Let's say this is a 6-inch curb height, so we'll change that to 0.5 feet. And let's change our gutter slope to -2%, just to stay consistent with our pavement surface. So I'll do the same thing on the right side. I clicked on it to highlight it. I right-click, subassembly properties, parameters tab, and we change the slope to 2%, -2%, and the curb height we changed to 6 inches or 0.5 feet. So if I apply and OK, we now have symmetrical curb styles. And the parameters are going to depend on your project, obviously, but wanted to show you how to access those parameters so you could modify these subassemblies to your need. So again, continuing with our urban road design, generally we want to see an inside boulevard and then maybe a sidewalk and an outside boulevard. So if I go back to my curbs tab, we have something called urban sidewalk, which is very convenient since we're building an urban road. And let's click this so we don't see that message again. So again, I am in the urban sidewalk command, and it's asking me to select marker point within the assembly. So where do I want to attach it? I'm going to attach it to this attachment point. You can see the circle lights up, and there we've got some sidewalk. Same thing on the other side. And escape out of the command, and I've added some sidewalk. Now I know I said we want to have some boulevard between the curb and the sidewalk, which is typical in modern design. So if I click on the sidewalk subassembly to highlight it and right click, I can go to subassembly properties. And in the parameters tab, look at this, we have inside boulevard width. So let's say I want an inside boulevard width of, oh, perhaps 4 feet. And a sidewalk width of 5 feet is fine. Outside boulevard width, let's go with 4 feet again. And then I can apply and OK. And you can see now we get inside boulevard, we get some sidewalk, and we get outside boulevard. And notice it is sloping toward the road, which is typical, toward this gutter. So we're going to be able to catch any runoff from the boulevard area or the sidewalk. And I'm going to do the same thing on the right side. I'm going to click it to highlight it, right click, subassembly properties, go to the parameters tab, and we set that inside boulevard to 4 feet, outside boulevard also to 4 feet, and a sidewalk width of 5 feet is fine. And here's that slope, 2%, positive 2%, because it is sloping back toward the roadway. So as soon as I click apply, there's my boulevard getting added, and then OK. So we're getting close to having a full urban road assembly here. The last piece we might want to add is a daylight subassembly. And daylight basically is how do we want to tie this this road cross section into the existing ground? Do we want it to just stop right here and have perhaps a straight wall? Probably not. A vertical wall, it's not a very good solution, especially if this is an urban sidewalk. The ground surface is going to be tying back at a slope probably to some building or other structure. So we need to figure out how to find the existing ground with our assembly. And to do that, we have a daylight tab. And we have all these different kinds of daylights. The daylights are probably the trickiest part of putting an assembly together. They're some of the trickiest sub-assemblies. And they are very specific. So do we want just a general daylight? Do we want to daylight to the inside of the right-of-way? Do we want to set a max offset or a maximum width? And so on and so forth as we go down the line. But let's say that we have a specified width from center line that we want to stick to, and that would be a good choice for this daylight max width. So I'm going to use that subassembly right now. And I will click on the outermost connection points. And it does put in some daylight subassemblies, so a solution to find the existing ground. And the default for that subassembly is to go up or down at 4%, or I'm sorry, at 4 to 1. So you can see, again, up or down at a 4 to 1 slope until it hits the existing surface. Or, in this case, until it hits a maximum width. So let's say right now the maximum width, let's set that to 5 feet, just arbitrarily. It's going to depend on a lot of things in real life, like how wide is your right-of-way, what's the existing ground doing, but for this video, we're just going to change our max width to 5 feet. And a 4 to 1 slope, that's pretty steep in some cases. Maybe I want to change that to a 5 to 1 slope. And all I have to do is type in the whole number 5, and it automatically gives me a 5 to 1 slope. So we're going to change that 4 to 1 to a 5 to 1. So watch it change when I click apply. There it goes to 5 to 1, and it has shortened up the maximum width to 5 feet. I can click OK, and I'll I'll do the same thing on the right side. I'm going to change these to a 5:1 slope and a maximum width of 5 feet. So apply and OK. So now we have a subassembly, and this subassembly is going to get placed along our alignment that we created, and it's going to place that subassembly at regular intervals along this alignment so that we can finally build a corridor model. And we will pick the corridor up in our next video.